Okay, so hi guys, welcome to High Entropy. It's day 25 of AI learning. So what exactly we are doing so far? So let's start with simple diagram and I will tell you. So far what we covered LangChain, MCP servers, how to build, and Cloud. So we got basics of Cloud. So I have learned so far Cloud and MCP. Another thing is LangChain, and now we are learning Langgraph. So we learned so far what we learned. We learned how to in line graph if we talk about line graph only. How to build graphs. Okay. So yeah, so far we learned this. Now there are so many things, and yesterday I watched and performed hands-on hands-on okay on how to create how to create conditional edges and a tool calling, and it calls automatically if required. Okay, so yeah, so far we covered this thing, and what we are going to do today. So first thing is we are going to make. I hope my internet will won't ditch me because it always happens. Like I'm streaming, but I don't know what happens, and it stops in between. So let's see how it goes. So far it's going good, I believe. Oh, my bad. Actually, I'm not sharing my screen. It's very bad. I thought I'm sharing because I haven't transitioned. So let me transition it into. So now you can see, guys. You can see me, right? Oh, my bad. Actually, I'm not sharing my screen. It's very bad. I thought I'm sharing it because I haven't transitioned. Let me transition it into. So now you can see. Okay, so I hope it will work. But my streams are completely bad, and simple reason is internet is somehow not supporting me. So I have to look for different uh, service provider maybe. Then only I'll get perfect internet. Hoping so, but it's not working, helping me so far. So it's better to upload videos. Okay, by the way, let's focus on our Langgraph. So what are we going to do? First, let me set the timer of 1 hour 30 minutes because I don't want to do something after. Wait a minute. Listen, initiative hai. What the fuck? Okay, let's forget about it. Why are you suggesting garbage all? I mean, for me, it's not important. I don't want to consume unnecessary content. Line graph. I can see it here only.
Whatever that LLM model thought at that moment that what tool call is required, it made those tool calls. Basically, not made tool calls, it prepared the input for the tool call. Our tool node created the tool, or basically made the tool calls. Then finally, this AI method was satisfied with the tool messages, and then it finally generated the final response using the news and whatever. Makes sense? Wow. Now, I will simply rerun this and you will see what will happen. So here, it will show the results one by one because this is streaming. This is like kind of real time stuff. See, so first of all, LLM node, that means me. Okay, I pass this information as human message. LLM node generated this then. Okay, then it made a tool node. What is really with the tool call? So it made this tool call and this it made, and then it just simply made the LLM node. Here it only generated one tool node because maybe it only required one tool call this time. It only depends like what does it think at that moment. Not think because LLMs are not think, but yeah, whatever it feels like. LLMs cannot feel. Yeah, you got my intent right. Okay, very good. So this is all about the React framework or let's say building React agentic AI frameworks with the Langgraph. What is the difference between this and LangChain? You have full control, right? You have full control. Very good. Now let's talk about the other framework available other than React because we have some amazing frameworks like obviously React is the best one, but we still have like amazing frameworks available. Let me just show you what are the frameworks available. Go to Langgraph official documentation, and here you will see workflows plus agents. So if you just expand it, you will see one is prompt chaining. Prompt chaining is the one that you have already built. Okay, there you go. simply pass the call and you see the result. And parallelization is very important. Let's say you want to create a parallel workflow. Okay, where you just want to create, let's say, two branches. You can create parallel workflow as well in the Langgraph. Now let's try to create this thing. Okay, now let's try to build this thing and learn this thing one by one. Let me just copy this React agents, and here I will say other workflows, or you can say other important workflows, or you can say workflows. Okay, because you just need to understand what are the workflows available in Langgraph, and then you can just use the creativity and you can just build anything. First of all, we'll just talk about let's say prompt chaining. And prompt chaining, by the way, is already done. Okay, how? Because you created this particular, you can say tool bounding and prompts and chains and messages, and let's say when you just use a React agent, you automatically use the prompt chaining method. For example, let's say not even that one, let's say finite one. So you build this graph. Let's say this one. So this is the kind of prompt chaining. Then you pass one prompt to one node, then second prompt to next node, then third prompt, then fourth prompt, and so on. So this is called prompt chaining. You can just connect multiple nodes one after the other using the prompts, using the text, using the input. Make sense? But there are scenarios when you want to generate, or basically you want to create the workflows in parallel. Very good example is, let me just open my whiteboard. So let's say parallel. What was the name of it? I want to use the exact name. Parallelization. Okay. Parallelization. So in the parallelization, and prompt chaining is already done. You can just use any example. Let's say this one. This is also kind of prompt chaining. Simple. This is also kind of prompt chaining. Now in the parallelization, what you want to do? You need to run nodes in parallel. Wow. Yes, you need to run the nodes in parallel. Let's say a very good example is, let's say you are the developer, okay, and you want to run one node for, let's say, one task, okay, and second node for the second task, or let's say third node for the third task, let's say. And what task you can just build with this? Anything, it's up to you. Let's say one task is just, let's take the same example. Let's say these three tasks are generating your posts, okay, social media posts. Simple, the same way that we just worked before. Okay, makes sense. Let's say you want to just create these social media posts, but in parallel. So let's say you have social handles on LinkedIn, Insta, whatever. So you want to write a post on a specific topic, but obviously the tone, the, you can say, style is not the same for all the platforms. But you want to automate this thing. So what you can do, you can pick one topic and you can parallelly create three different posts for three different platforms. Yes, in parallel. So let's say this is for Facebook. Okay, this is for, let's say, LinkedIn, and this is for, let's say, Insta, and this is, let's say, Twitter. It is X. Okay, so you can just perform this thing in parallel using parallel workflow. Let me just show you how you can just do that. So if you go to, let me just create a new, yeah, let's say, let's get a new one. Okay, and for this we don't need to create a React agent. It will be like very simple, and we don't even need to create tools because we are simply now learning more about the workflows, right? Now you know towards the React agent. Now we're just working more about, you can say, working more towards the workflows. So I will simply, let's say, copy this one. Let me just rename it. Let's say parallelization. Simple. So in the parallelization, I will simply run this cell, and let me just attach the virtual environment. Okay. So now here I will define a pydantic schema. Pydantic schema, or you can say a kind of typing scheme. It's up to you. Like, it's fine. Let's create the typing scheme. It's not a big deal. So because now you know the stuff. So from typing import it will be topic, which will be same. Then I will create one Insta. Okay, this will be string. Then Twitter. Then LinkedIn. Simple. Yes. So this is my schema. So here I will say create post. Simple. And here I will simply say create post and then let's say LinkedIn or let's say Insta. Simple. Very good. You can also add some instructions. Let's say keep the tone casual and engaging because it's Insta, right? Then you can write here I will say, because on Twitter you cannot LinkedIn. Perfect. So these are the three nodes of my nodes. The first one with the start, and I will simply say create post Insta. Okay. Then it is saying create post Insta, then Twitter, and LinkedIn, and LinkedIn, and create post. No, I don't want to create it like this because this is not parallel. This is series. So what I will do, I will simply say graph.add edge and create from start. This way it will simply create all of the nodes in parallel. Makes sense like this. Wow. Yes. That's exactly you need to build the graph. This is the only difference. Now let's compile the graph. Let's see what do we get. Perfect. I got my graph. The exact same graph that I want to build. Simple. And compile the graph. Let's see what do we get. Perfect. Yes.
Okay. Start to end.
That's exactly you need to build the graph. This is the only difference. Now let's compile the graph. Let's see what do we get. Perfect. I got my graph, the exact same graph that I want to build. Simple. And you can even, let's say, invoke it. Let's say parallel graph. Parallel graph. Let me just run it. And let's say parallel graph dot run. And let's say we want to write something for artificial intelligence, right? And you can just simply pass empty strings for other keys. Combined state graph is going to run. Wow, wow, wow. Not run. Who said run, bro? It's invoke. This AI generation sometimes like as not like model dump makes sense because we have used it. Model dump, not a big deal. You can ignore it. You can ignore it. You can ignore it. Now save, run all. Simple.
Simple.
So now we should see it running. Okay, it's rotating. So let's wait. So that will just create all of the posts in parallel on all the platforms. Happy? Now just
Rotating
post about. So yeah, you can just post about it, Shamba, and just post about this amazing YouTube video and this error. What is error? At T topic can receive only one value per step. Okay. Use an annotated key to handle. Oh, I see what is like actually happening. So you know what is happening right now? It is simply trying to update. So when you simply returning something. Okay. So it is simply trying to update the key, the topic in you can say parallel. Okay, in parallel. So when you are simply returning anything in parallel, it can create some context. So that is why it is simply saying if you want to update anything in parallel, you can just use annotated. Simple. So here, what is the quick fix? First is you can create annotated of list. Let's say like this, annotated, and then string or whatever. Okay, because that can just simply change all of those things. And the better way is instead of returning state, that means instead of returning entire state, because when you return the entire state, that means you are trying to update the entire state. Even the value is same, but logically you are returning the entire state. You can simply say return state of insta. That's it. So this way you are only updating the insta, not the entire state. This is a quick fix for it. And not quick fix, quick knowledge transfer as well. I like to share like tips that I learned along my way because I also faced this error during my learning days. That's why I was like immediately like, oh, I have seen this error before. So yeah, I found it and then I thought of sharing it with you. I hope it's helpful, right? I hope it is helpful. Now let's see. Okay, now I think it's working fine. 3 seconds, 4 seconds, 5 seconds, 6 seconds. Install how to like that. So yeah, I was saying like, yeah, you can just post about this amazing YouTube video, share your learnings, tell about the learnings. Go! Your lessons or whatever. What is this? I think something else has happened. Okay. Invalid update error. What AI use case are exploring? I think it has returned something. Okay. And it's saying during task with create post LinkedIn and ID. Okay. Output is truncated. Scroll over let me check. Because it returned something and it's saying expected dictionary. What AI is no longer futuristic concepts factors. Ooh, I think something is wrong. It is saying, okay, topic is this one. Okay, makes sense. Install Twitter LinkedIn. And it is saying that it failed at create LinkedIn. Okay. State of LinkedIn, state of topic. Interesting. Let me check. So the error is fixed within 2 minutes. Yeah. So the issue was same, but because the fix was different. The issue was same, like it was just updating the same key. So what I did, I simply returned the dictionary only, basically that key, instead of returning the state. Makes sense? So it fixed the issue, and you can also say, so intent is still the same. We simply want to update only the Insta key, or basically Twitter key, or basically the LinkedIn key of that particular scheme, not the entire scheme. But when I was just returning the state and then dictionary, it was maybe like making some conflicts in parallel. This happens in parallel.
Okay.
Execution. So now it is working fine, absolutely, and as you can see, your all the 3 ports are ready with different content and in parallel. These are not running in sequence. Very good. So this is all about the prompt chaining and parallelization. Now let's talk about the orchestrator worker. By the way, orchestrator worker is one of the most complex one. We'll talk about it at the end. Okay. Now I want to talk about the evaluator optimizer. Okay, evaluator optimizer. Now, or let's say before talking about evaluator optimizer, I want to talk about routing because this is very important and very easy. So let's quickly cover this one. Routing. What
भाई हो जा. Come on, man.
understand by routing? Routing means maybe let's say a kind of route which can just divert the flow exactly. So when you have the flow like this, let's say routing. So here what will happen? You will create let's say these 3 rows as this. Okay, as this. Now you will not take a decision. Okay. Now you will add basically you can say add a kind of route. Okay, add basically a kind of route. Now this route will decide in which direction we need to go. Wow, this is called router. Makes sense? So let's say we have so many nodes, we have 3 nodes, the nodes that we have created. But this time we want to involve a router to tell and to make the decision that whether it should go towards here, or towards here. Okay, and how we can just create the thing? See, under the hood, what is route or what is router? Just think about it. Just think about it. Under the hood, router is nothing but just your conditional logic. The condition that you build. Yeah, kind of. See, kind of right. So now you need to build a kind of workflow which will actually take you towards only one node. So now let's try to apply this thing in practice so that we can actually learn about it, like how we can just perform all of these things. Make sense? Just just understand it. Okay. So now in order to apply this router, you need to learn one more concept and it's very interesting. Let's talk about it. So I will go to my VS Code editor. Perfect. So now what I will do, I will simply, let's say, close this. Perfect. Rename, let's say 8 and router. Here the requirement is very simple. I need to create either LinkedIn post, Instagram post, or whatever post. Okay. But now I will not tell LLM beforehand. I will not tell. I will just write a message on its own. Okay. And then LLM should be able to find the intent, like what exactly I need to do. And this is the concept that takes us towards the direction of structured output. Because LLM can generate answers on its own so far, but now we have a concept called structured output. Same way LLM got with bind tools. Okay. Similarly, we can also, you can say, make our LLM powerful enough to only generate the response with a specific scheme. Okay. It's called with structured output. Okay. With structured output. You simply use it. So first of all, what I will do, I will create that schema. So here I don't need to use identity schema. Okay. I will change here as well because this is not identity schema. This is a schema. Perfect. So here I will go to identity schema because this is my identity schema that I want to create. Simple. So here in the identity schema, we will say LLM identity schema because this is just for the LLM. Here I will say from identity import base model and just be with me. This is like a little bit complex, but it is very handy and very helpful. So let's say class. This is LLM schema, not the graph schema. LLM schema. Here I will say topic and string. And you know what? You know what? I will not use topic and just as a random string. I will pass on some rules. I will say I want topic is of literal data type. Literal means only these values should be allowed. First of all, Insta, then Twitter, then LinkedIn. Simple. And I can import from typing import literal. You know what? Now, if I just, you can say, take this LLM, okay? It will only generate the answer with this key called topic. Let me just show you. So I will say, and I can also pass some description because it doesn't make any sense like what is this literal, what is this choice, or what is this list, right? So I can literally say field, and after literal, I will say field, and description is topic for which to generate the post. Very good. Now, if I just call this LLM, okay, which LLM? Then I'm just going to create. So LLM with schema, and I will simply say, this is my LLM, which is automatically created. Let me just run this. Let me just run this. Okay, this LLM is running. Just run it quickly, bro. I don't know, but these nodes are running very slow today. Very slow. Okay, so I will simply say LLM dot with structured output. Okay, with structured output. What type of structure? LLM schema. This one. This one. Now, if I just try to use this LLM, if I say LLM with schema and dot invoke, and if I say I want to generate a post for Twitter and post for Twitter about, let's say, AI. Simple. Let's say I want to do this. So do you know what? Description will be much more detailed. Description will be much more detailed. It will be category of the post to generate, right? Now LLM will automatically tell me what is the category of the post. I have written, yes, I want to generate a post for Twitter, but LLM will automatically interpret that the topic value will be Twitter. It will not be Insta, it will not be LinkedIn on the basis of the input. See, topic equals to Twitter. Wow. This is called structured output. And if you just look at the output, it is not generating something called as AI message, tokens, whatever. It is generating the response in the form of identic object. This is the major thing. This is the major thing. Makes sense? Very good. So now we know that we can just create our LLM with a structured output, right? Very good. So we will create, you can say two objects. One is LLM with schema, right? And one is simple LLM that we need to just use to generate the content, and that's it. Because this LLM with schema will only be used when I just want to generate this particular value, and that is it. There is no other use of this particular schema. Simple. And this is my state schema. State schema. Okay. State schema is very simple. And here I can simply say post because it will be just one post. Simple. And there will be no topic by the way. It can be topic. Okay. There can be, but I don't think I should just pick the topic. I will simply say input. Okay, input, that means whatever I want to input. Post is the real post, and I can create one topic key that will be populated by LLM. Okay, perfect. No, we don't need to use literal. Perfect. So what I will do, I will say create post, perfect, create post Twitter, create post LinkedIn. These are like as it is. These are like, there's nothing wrong in that. Makes sense? There's nothing wrong in that. Only one thing we need to change here. I do not need to pick that topic like this. Okay, what do I mean? Here, I can simply ask LLM to generate that topic as well. For example, currently we are simply finding the topic, right? Like which topic you want to use or whatever. Let's say I will change it to category. Okay, I will change it to category. Simple. And here I will say generate one topic as well. Topic of the post to generate. Simple. Now let's see what it will return. So it will automatically curate the topic which can be easily be used by LLM to generate something. This is a kind of query curation. We are just learning very deep concept, but this is important for you. Okay, so one thing is like just scratching the surface. Other thing is going deeper and learn the real skills. So we are learning the real skills. So as you can see, category topic, category Twitter, topic is here. Perfect. Perfect. See, that's how we can just work with the query curation. Simple, very good. This also saves the tokens, right? Real world lessons. Okay. So now we have this particular thing: create post Insta, create post Twitter, create post LinkedIn. Very good. Now I need to create one node, which will be a decider node. So I will say df decider node. Now this node, what this node will do? Let me tell you. So this node will first of all take a, you can say, user input or let's say state. Simple. So I need to take this input. Let's say input. Now in this input, I will pass it to what? LLM, right? And which LLM? LLM with schema. Very good. I want you to see like if you are just following along. LLM schema. Simple. Then you can say dot invoke and user input. Simple. And then dot category. Why dot category? Just tell me why dot category? Because this is an identic object. Identic object. Simple. You have the identity object. It's enough. So now you have the category. Now then update the category. Right? Update it. Simple. Simple. Over. It's done. Return state. Simple. Now what will happen? Now what will happen? We have the state ready and we have got which category we need to pick. Right? And these are the nodes. Let's create the nodes. So simply run this function. All the functions. Graph schema is not defined. Okay. At least run that as well. Okay. So this is also done. Now we simply need to create the schema. Or basically not schema, like state graph. Right? So here I will simply get rid of these things. First of all. And let's try to create the add node. First of all, I will say add node, decider node, create Insta, create post, for Twitter, LinkedIn, whatever. These are the major nodes. Now, if you just look at our requirements, this will be the conditional edge, right? Let me just make it dotted. These will be the conditional edges, not the direct edges, because you cannot run all of the edges. This will be conditional. So let's try to write the logic for the condition, right? So here, what will I do? I will create a new function. I will say df condition. Okay. And then I will, not boolean basically, I will simply say string. Simple. And now you have built the application, so now you know how to do it. So simply specify the category. Okay. And perfect. So if the category is Insta, then go to create post Insta, create post Twitter, or create post LinkedIn. Simple. You know what we are doing right now because you know how we built the application. What is the condition, right? Very good. Very good. So now let's try to write the edge. So first will be decider edge. So like decider node start to decider. Then graph dot add edge. Decider, not decider. Basically now add conditional edge because now conditional edges will be coming into the picture, right? So this is decider. And decider, just the name of it. Okay. I can also say condition just to stay consistent. Okay, condition, and this will be my condition function that I have built, right? I don't need to apply mapping because I'm not applying any kind of mapping there, so that is fine. Simple. Good. So here, once we have the conditional edge, then I will say graph dot add edge, and I want to create an edge from condition, not condition, basically from decider, right? See, so decider node is here. Okay, decider node. Decider node is here. Now we need to make sure that this decider node will be connected to this one, and this one. Simple. Okay, so let's try to build that. So decider to, you can say create LinkedIn. Simple. And graph of add edge, this one, and then same to end because you also need to end it. Simple. Very good. So that is it finally, and now I can simply run this graph by compiling it.
Add conditional is condition. Start decider will come into picture. So I have doubt on
Simple.
this.
So let's say round graph. I know this was like complex one, but I want you to learn complex thing. Everyone knows the basic stuff. This is the thing that you need to learn. Simple. Graph dot compile. Because if it would be so easy, everyone would have done that, right? Right. So let's try to run this. Condition is not right, obviously, because we didn't run this function. Let's run this function and let's run this. Found edge starting with unknown node. Create post Twitter. Okay. Don't we have that node? Create post Twitter. Which node? Okay, so we have create. Oh, we don't have create post Twitter. We have create Twitter. This AI implementation sometimes like, oh man. Simple. Now it is saying a condition. Now what do you want? So the condition is, where's the condition? Okay, add condition edge condition. So this is the condition. Okay, this is fine. And condition.
Yeah, I heard doubt.
Okay, let me read the error message. Found edge starting at unknown node condition. Obviously, who started the node at condition? We cannot start the node at condition. Add conditional edges. Oh,
Decider to
decider. Again, see AI condition. We're usually smart enough. Wow, so this actually worked fine. Now you can see that our decider node, okay, is connected to Insta.
Wait a minute. Oh,
add conditional edges. Oh,
okay. Wait a minute. Decider to condition we are going. So decider, the node that is going to provide us the what are the different ways. Okay.
this is not condition. This is a decider. Again, see AI condition. We're usually smart enough. Wow, so this actually worked fine. Now you can see that our decider node, okay, is connected to Insta, LinkedIn, Twitter, and then all are going to end. Simple. I know this was a big one, but you finally did it. That's a very good thing. Okay, that's good. So now you can do one more optimization. If you look at the graph, you are seeing the solid lines instead of dotted lines. Do you know why? You know the answer. That's why I written it. That's why I wrote it here, so that you can just understand it. If I say add edge, and if I'm just creating a solid edge, obviously to create a solid edge, it will not remain like a conditional edge. So you do not need to create any edge from this side because that logic is already handled here. That logic is already routing it here. Make sense? Let me just rerun it. Now you should see the dotted lines. Wow, it has removed something. Wait.
I have doubt on
Let's
this.
see what did we actually removed. Maybe we removed some extra stuff. I think everything's fine. It's just about this thing because it is writing create post. The previous error. I think now it should be good. Okay, now we can just move it. Now it's looking fine. Okay. What? Okay, I think I didn't say anything. Okay, let me just fix it. I think they have actually made this particular change for all of the mappings. It was not there
You have to
before,
use
but
mapping.
we don't actually do it. So the same thing that we saw in the React agent thing, we have to provide the mapping like this. Earlier, when we used to work with the previous versions, it was optional, like we can provide the mapping. So yeah, this is the thing. So I can also check the documentation, but it is not written there. So earlier, when we didn't have this particular way, so if we just write the exact node date, it was working fine. Like you do not need to again mention it in the mapping, but I think they have just made it
Okay, decider is relevant.
mandatory, but it's fine. It's their package, whatever they want to do, it's done. We are developers, we know how to debug, and that's done. Okay, so this is done by the way. So you have created this dotted lines, okay, and this is your graph. So now what will happen if you just want to run it, and if you want to, let's say, invoke it with the initial input, and the input will simply say, I want to generate a post for Twitter about AI. Simple. The rest of the things will be automatically generated, obviously. So you do not need to pass any kind of topic. Why? Because AI will do it. Then you can say category, and category will be again empty. Okay, makes sense. And then post. Perfect. Now let's try to invoke it and see invoke. What does it say? We didn't have decider and we didn't have the name decider. Okay. So I want to generate a post for Twitter AI. I first want to check the schema if it is fine. So the schema for our data. So we just have three things: input, topic, and post. Okay. Input, topic, and post. We don't have any kind of category. Input, topic, and post. But why? We should have like four things as well. Category. I think we just forgot to add. Let me try it quickly. Category. Yeah. Obviously there are things there. Let me just say run all. And now let's wait for it to run. Okay, now it's running fine. Let's wait. So bro, there were so many silly mistakes in this particular code. So I just fixed it quickly. So first of all, we used LM scheme instead of LM with scheme, and we want to use LM with scheme obviously. So that's a typo. Second thing, if you just notice one thing, we forgot to pick the topic from that particular response, which is a common sense, right? So we forgot that. So I just simply added it, and now it is absolutely good, absolutely amazing. I haven't run this code, but I wanted to show in the parallelization. We had run it in front of you so that you can also see. Yeah, let's wait for it to run and complete. So now let's wait and see if our error is gone. Meanwhile, we can just talk about the other frameworks as well, or the styles with the other kind of frameworks. So this is this one. So now we're just looking at this evaluator and optimizer. This is very important. But before that, let's talk about orchestrator worker, because this is very fun and this is actually really amazing. Orchestrator worker, and this will just test your multi-threading, Python multi-threading skills. Don't worry, we'll just talk about it. And by the way, this is very good, very good. So yeah, there was some silly mistakes in this particular code. So if you're just watching this particular segment, so just make sure you are using the my updated notebook, or you can say Python Jupyter notebook, which is updated. So there are some silly mistakes, okay, that we just simply updated, and now it is running absolutely fine. Simple. Okay, very, very, very good. So now let's talk about this amazing architecture. It's called orchestrator worker. And let me just tell you, this is a kind of advanced architecture. But nowadays, since the beginning, if you want to work with any kind of agentic, you can say framework, then this is the one that every organization, every single organization uses. Why? Because let me just first explain that, then we'll automatically get the answer why. So let's say you are a user. Okay, let's say you are this user. Simple. Okay. Now this user can submit multiple tasks in a single prompt. I want to get this, I want to do this, can you please do this, can you please do this, and done. Obviously, right? You can submit multiple tasks in single prompt to the LLM. Simple, very good. Now, obviously, LLM can perform these tasks in one go using the prompt, because LLMs are like advanced enough nowadays. But what if in your query, in your question, you want to perform specific tasks that LLM cannot do alone? Maybe LLM might need to make some API calls, some tool calling, or even forget about tool calling and API calls. We know that our LLM can handle tasks in parallel, but if we want to generate the accurate answers, the good answers, we need to just submit the tasks one by one. Make sense? Yes. Here, when I said one by one, that doesn't mean that I have to just submit one task, then wait for the answer, then second, then third. No. I meant to say that we need to submit an independent task in chunks. Make sense? For example, I'm saying, what is 10 plus 10 and what is the temperature in Dubai right now? So obviously these are two different tasks, right? I need to submit these two questions separately. In parallel, yes. In series, yes. That is a different thing. We can just submit those questions, maybe in a series or parallel. That's not a problem. But the concern is I want to just make different requests, right? So okay, here comes this architecture, and this is a kind of architecture that we use in the real world. The above architectures that we have learned are just the micro components of the bigger architectures. We can use routing in our big architecture. We can use parallelization in our big architecture. That is just like small components. But orchestrator worker is a kind of complete architecture, and obviously an advanced one. Earlier I was thinking like, should I just teach this as well? Because this is a kind of very advanced topic. But I know it will require some extra efforts, but it will be worth it. And just hit the slide button like now, okay? Just hit the slide button if you find this topic helpful. Make sense? Okay. So now let's talk about it. So what will happen? I will submit my query to the LLM. Let's say this is the LLM. That is the same thing that we're doing so far. Simple. Okay. So this is done. This is not a big deal. We know that we can just do this. Simple. But now I don't want to directly submit my query, which has like so many questions with it, right? You can say uh, so many questions in a query, right? So what I will do now, the real work will be started. Okay. What kind of real work? Let me show you. So first of all, I will send this query to the LLM, and you know what? This node, this LLM node, will be called as orchestrator. And you know what this node will do? This node will not execute anything. Okay. This node will create a list of tasks. This node will create a list of tasks. Okay. Simple. Okay. This will create a list of tasks. That's it. Because this is an orchestrator. This cannot perform anything. This will simply orchestrate. This is responsible for the orchestration. Simple. So this will take your query and it will generate the list out of it. Wow. How? Obviously, we just see how. So this will create a list of tasks. Make sense? Then comes the worker node. Okay. Then comes the worker node. So let's say this one. So this worker node is very special. This worker node will perform obviously all the tasks. Common sense, because we need to perform the tasks, like we need to execute the tasks. But now you know what? This worker node, this one, will not perform tasks in one go, or let's say perform tasks one by one by one. No. This worker node is special. This has multiple threads. Okay. This has multiple threads. So let's say thread 1, thread 2, thread 3. And these threads are dynamic. These are purely based on the number of tasks that we have in the list. Let's say in our list we have 3 tasks. So we create 3 threads. If it has, let's say, 10 tasks, it will create 10 threads. If it has, let's say, 20 tasks, it will create 20 threads. And it will perform the execution automatically, parallelly, to save the task, like to save the time. So this node is called my worker node. This entire node. Simple. This node is called worker node, which is having threads, right? Okay. Now you will say, Anshilamba, yeah, this node can perform these tasks, right? Yeah. So how to perform this task? Like, what will be the execution thing that we need to execute? Because we need to execute something, right? Exactly. So when this will create multiple threads, it will create threads on top of a specific function. So this will be having a kind of function. Simple, let me just write. Let's say function. So this will run the threads for function in parallel. Wow. Makes sense? And then once everything is completed, okay, once everything is completed, then we can have a kind of collector task as well, or you can say collector node as well. So this will simply collect all of the results of task and it can just generate the output to you. Okay, it's like optional thing, but it's good to have them. So let's say this is a collector. Okay, so this is called collector. That means we'll collect everything. Simple. So I can say this will collect the result of task. Perfect. Simple. And then finally, you will get the response back by this collector. Simple. This is the entire architecture, and this is a complex one. Okay, you have to be very careful while building this.
Wow. It sounds like it's kind of similar to Spark. I feel orchestrator is like a driver, worker nodes are like executor, and the final monitor who can say correct. Let's see how it goes.
So this is the architecture that we build in real life. I hope it makes sense. Okay, this is the architecture now we're just trying to build it. Makes sense? Let me just open my VS Code. Let's try to do this. Okay. So now, first thing first, let me just create a new notebook. And let me just say orchestrator worker.itind. And yes, you might be watching this segment of the video multiple times because this is actually important and this is a little bit critical. Okay, and obviously complex one as well. So first of all, what you need to do, just import the boilerplate code. Simple. So let me just import the boilerplate code from here. Simple code and select kernel. This is the kernel. Run this. Okay. So let's create the LM object. Just get the code from here. So okay, perfect. My LM object is also created. Now you need to create a special node which will create the list of tasks, right? So you have already worked with a scenario where your LLM just generates a kind of schema. If you remember in the routing part, we learned that we can create a special LLM object which will generate the specific output, right? So here you know what we will be just doing here. So here I will be creating a kind of identic schema which will generate the list of tasks. Simple, because I want to use that. Like, what are the list? Make sense? Okay. So what I will do, I will simply say identic LLM schema. Simple. So here I need to generate the schema for the, you can say, LLM. Because see, when we will be just creating our main schema for the graph, obviously we need to have tasks. That is the common sense. Who will generate that task key? This identity element. Makes sense? Because we need one element which will only generate the output in the form of specific schema. Because we need a list, right? Very good. So let's create the one. Who will generate that task key? This identity element. Task with it. LLM schema. Simple. So here I need to generate the schema for the, you can say, LLM. Because see, when we will be creating our main schema for the graph, obviously we need to have tasks. That is the common sense. Who will generate that task key? This identity element. Makes sense? Because we need one element which will only generate the output in the form of specific schema. Because we need a list, right? Very good. So let's create the object. So I'll say class.
It's like orchestrator.
LLM output is, let's say, LLM schema base model, and here it will be, let's say, tasks, and this will be list. Let me just import from Python import base model, from Python import list, and I also want to import field because I want to provide some description. Because LLM can better understand the things than field description. A list of tasks. Wow, very good description. So now it is created. Now I can simply create LLM with schema equals LLM dot with structure output, and this is the LLM schema. Perfect. Now let's try to test it. I will simply say LLM schema or LLM with schema dot invoke, and I say what is what is the capital of France and what is the population of France? Let's say two different questions, right? Let's see what we get. We should see a list with two tasks, right? Let's see. Yes, what do we get? No, it has just picked the one, so I can just be more specific. Or we don't need to be more specific here because this is just a data type. We will be more specific when we will be calling this LLM with a kind of, you can say, template, right? Because we don't need to call it this thing. We just need to test it here that it is returning a task list, and that's it. The task items within the list, we will be just manipulating it during the invocation in our graph, right? So that is fine. We don't need to be very specific here because this is just a description for the list that it is returning the list. Simple. Okay, so this is fine. So our identity LLM schema is created. Simple. And our LLM object is also created. Now let's define the schema for our code. So I will say graph schema. Simple. And here I want to create, let's say, graph schema and type dect. Perfect. So here what do I need? I need, first of all, tasks. First of all, tasks, obviously. The tasks will be listed. Then what do I need? I need, let's say, because that's the only thing that we need, and obviously query by the user. Okay, query is straight. So these two are the mandatory tasks that we have. And then we will also create one more, you know, the key that is called results. And this will be also a list. Why list? Because we'll be having multiple tasks, right? So let's create a list of it. Simple. And just as you can say a kind of optional key, we can also say summary. Let's say we want to provide the summary as well to the user that hey, these are all of the answers that we have provided as per your questions, and it will look good and it will be more professional. So this is the graph schema, right? Class graph schema, and this is the schema. So I have created this and type it as modified. Let me just run this. Perfect. So my graph schema is ready. Very good. Now I need to create the worker node. Oh, sorry, orchestrator node. If I just want to see my chart, orchestrator node will create a list of tasks, right? Let's try to create this. So I will say create an, let's say, worker node. Not worker, orchestrator.
Orchestrator.
Simple. Okay. So now what I will do, I will create a function here, and you can say orchestrator node. It will take state, obviously, of graph schema, and we will generate the graph schema. Okay. Yeah. So first of all, I will get the input. Right? First of all, the input that I want to perform. So I will say query or user query equals to state of query. Perfect. Fetching the user query. Simple. That is the first thing. Fetching the user query. Perfect. Now what I need to do, I will generate a prompt because I want to be very, very specific because I want my LLM to generate the accurate answer. And obviously, whenever you want to generate accurate answer, we should always use prompt because prompts can guide LLM better. So here I will create the prompt. Create the prompt for LLM. So I will say prompt equals chat prompt template, not from messages, and we do not have chat prompt template. Let me just remove call it from. Perfect. And from messages, let me just create the list. Perfect. So here, let's see what it has written. You are an orchestrator that takes on user query into tasks for the worker. Very good, very good. That is a very good system message. And let me just modify the user message. So user query is this. Perfect. Please break down this task in the list into a list of tasks for the worker to perform. No, I will be very specific. I will say, please generate one prompt or task for the worker to complete. Very good. Let's try to use this prompt. Okay, and let's see how does it behave. So okay, this is the thing, user query. Okay, and user query is here. So this is my prompt. Simple. Now, when I will be calling the LLM, I will simply pass this prompt. Simple. I can simply say, now I have two options. I can also invoke my prompt right now. So because I obviously need to fulfill this thing, which is user query. Okay, and then I can simply call the LLM, or I can create a quick, you can say chain. Okay, quick chain. So let's create a quick chain because now we know the fundamentals of language. Quick chain. Let's say create the chain. So chain will be first of all prompt. And then LLM schema. Why did I create chain? Because I don't want to use dot invoke two times. This chain will just do the work. Okay. So this is my chain. Now I can simply invoke the chain and that's it. So I'll simply say chain dot run. No, I don't like dot run method. I like invoke. Okay. Query equals to user query. Perfect. So now this response should have the task list. Yes, the task list. Update the task list. Perfect. and we have got
Should
response,
we use
and
it?
it has performed response dot tasks. Response dot tasks, yes, because this will be a kind of dictionary. I think it should be response of tasks. Let me first of all check, because obviously we need to test it because we haven't tested it. So let's try to test it first of all, because I don't know if it will work or not. Like obviously I know it will work, but this prompt needs to be tested. Okay. So now here I need to pass the user query. Now I will simply say user query correct for Paris. So let me just provide any random thing. What is our capital of France and what is the population of Paris? Yeah. So we need to make sure that this response will generate the list, right? Let's see what we get when we run this. Let's see. This is a testing case. Perfect. Very good. This time you can see the tasks list is actually a kind of list of two items, different items, right? Wow. And this is the first one. Okay. And this is the second one. Very good. Very good. And if I just say response.task, this is a identity object, obviously. Because LLM schema is a LLM which is bind with structured output. Okay. That's exactly what I need. Very good. This is tested and this is working absolutely fine. Perfect. So this is good. My orchestrator node is done. Now let's create a worker node. Okay. And worker node is very, very important. Obviously, orchestrator node is also important. Worker node. Now let's tell you one thing. If I just go back to my architecture, I need first of all two things. First of all, the worker node, which will generate the parallel threads, and the function as well, obviously, because I need to generate the threads for the function, right? So first of all, let's create this quick function, which is nothing but just the element column. That's it. Okay. So I will go here and I will create the, you can say, this will be, let's say, execute function that you want to execute. Simple. So I will say def execute. Okay. And I will take state. Not state basically. I can take query and then string. Simple. And this will, yeah, that is fine. So now what it will do, it will simply execute the task and that's it. It will simply send the call or basically make the call to the API, LLM API, and that's it. That's it. And that's exactly what we need to do, right? So I'll simply say LLM or let's say response equals LLM.invoke, simple LLM, not LLM with schema, because this is like real execution, not the generating a task. So I will simply say please, not please, simply send the query, what is please? LLM will generate the thing. Okay. So LLM.invoke and query equal to query. No, we don't need to say query because we can directly say .invoke. Simple, because see, this list will be having our tasks, right? Or we can just, let's say, be a little bit polite. We can say, please execute this task. Simple.
This task.
Simple. Okay. We can say this. Please execute this task. And we can just return the response. Perfect. This is a simple function execute function. Now we'll be creating the main executor node, or basically you can say worker node, which is generating a parallel threads. And for that, you need to have a very good understanding of thread code executor that we use in Python. Again, Python fundamentals. Make your Python skills strong if you want to grow in today's era. Everyone wants to know LangChain, Langgraph, blah blah blah. Learn Python first. Learn Python first. It's all about Python. Okay, at the end of the day, it's all about Python. So now I will just using thread code executor. If you do not know about multi-threading and thread code executor, you can just go and just learn about it. It's a very good feature in the Python. Or modern Python, it's available in every programming language. Like how we can just generate parallel threads and we can execute our code in parallel. It is different from asynchronous behavior. Do not get confused. This is totally different. We are data engineers. We know it. So it's not about data engineer. Like if you are programming, you know about this thing, which is called parallel threads. Okay. So for that particular thing, I will need to, you can say, import one library, which is called thread code executor from concurrent.futures. Simple. So let me just do that. From concurrent.futures, import thread code executor. Simple. So now this thread code executor will do the real work. So I will say def worker node, and I will take the state of graph schema. Perfect. And here's it. First of all, I will write the tasks that I want to perform. Perfect. And I will create the empty list of results. Very good. Then this is the thread code executor. I will open my context manager. I will say with thread code executor. Okay. As executor. So this is fine. This is fine. Like this part is fine. But you know what? When we define this thing, we do not know like how many executors we need, or basically how many workers we need. Right? And what did I say? I will create a dynamic workers, right? Let's say there are 3 tasks, so 3 workers, 5 tasks, 5 workers, 7 tasks, 7 workers, and so many other things. So what we can do, instead of using the default workers, I will simply say workers, or you can say max workers equals length of task. Okay, length of task. So now, if in my tasks list, if there are 2 tasks, then 2 workers will be working in parallel. If 3 tasks, 3 workers will be running in parallel. 5 tasks, 5 workers will be running in parallel. Simple. That's how it works. Now I will use the map function. Like there are multiple ways to use that place. My way is I will simply say results. Okay, or let's say results or futures, because that is the type of naming convention we use, results futures, equals to, I will use executor, or let's say map function. So map function, what this map function will do, let me just tell you. So let's say you have a function, okay, this is your function. You can map this function to the entire list. So that, let's say 1, 2, 3. So this map function will apply to this, and to this. Again, by the fundamentals. Okay, so you need to know that how we can apply the map. Okay, so I'll simply say executor dot map. Okay, and what I need to map, like which function? The function is execute that we just created here. See, here. And to which list I want to apply this? Tasks, obviously, simple. So now you know what will happen. This task list will act as the input for my execute function. Oh, so whatever I have written in the tasks, in the, you can say, in this particular thing. So let's say if my task is having one item, second item, third item, right? So that item will become the input for my function. So just be very careful if you just want to use this feature in future. Okay, maybe in any other input for. So now you know, simply say executor dot map. Okay, and what I need to map, like which function? The function is execute that we just created here. See, here, and to which list I want to apply this? Tasks, obviously, simple. So now you know what will happen. This task list will act as the input for my execute function. Oh, so whatever I have written in the tasks, in the, you can say, in this particular thing. So let's say if my task is having one item, second item, third item, right? So that item will become the input for my function. So just be very careful if you just want to use this feature in future. Okay, maybe in any other workflow, just make sure that the item should match the data type of this function. If let's say in my list I am having dictionaries, I can have dictionaries, right? Dictionaries of a list of dictionaries. Then this data type cannot be string. This will also be like dictionary, and then you can fetch the values from that dictionary. Again, high level things. So not really about that. See, you will learn gradually. You will not feel like you do not know the things. It's all about time. It's all about practice. It's all about playing and experimenting. Okay, so it's fine. If you do not know the things, you are landing on the perfect channel. Just subscribe to this channel. You will know everything. Okay, so results futures are here. So what will happen now? Now all of the threads will be running in parallel. Yes, and now I can just save the results of every task smartly. You know how? Within the context manager. I will simply say for result in results future. Okay, and then I can append my this empty results. Okay, because we have to do it in the context manager. Otherwise, once this context manager is you can say completed or executed completely, then it will not save the result. It will simply release it. So we have to store it immediately within the context manager. This is the code, and then I can simply update it, return state, simple. This is the code that we need to build. Simple. Move on. Okay, this is the 90% of the code. Now 10% of what is like collector mode, which is the optional thing that you want to, let's say, collect all of the things and you want to say like what you have done and blah 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 blah. Right? Let's know it because that is also a good feature to know. So let's say your results is also populated with the AI messages, right? Obviously. So what I will do, I will create one node and I will say collector node. So this collector node will do nothing. It will simply say collector node, and this will take this, and this will say, I think it's suggested a good thing. Results, okay, results we can fetch from UI collector that summarize. Yes, exactly. So this prompt is a good one. UI collector that summarizes the results from the worker. Very good. And here are the results. We can just pass the results list and please summarize the results in a concise manner. Perfect. And then we simply need to invoke the element, and that's it. So our summary is also created. See, so now all the keys of the schema are generated. Simple. Take it. Perfect. And that's it. That's it. That's it. Now, finally, what? Simple. Now that you know the favorite part, crafting the graph. Now, I'll simply say creating graph and execute it. Simple. So here we can say graph. Let's say from Langgraph.graph import state graph start and very good. And bro, if you understood this concept, then obviously tap your back because this is not an easy one to understand. And yes, I put my best efforts to explain the things. You put double extra efforts to understand it. So it's a good win for you and you should celebrate it. Okay, simple. Let me be honest with you. This is not a very easy thing to understand. Okay, very good, very good, very good. So now let's build the graph. Let me be honest with you. This is not a very easy thing to understand. Okay, very good, very good, very good. So now let's build the graph. So graph equals to state graph and graph schema. Perfect. Graph dot add edge, not add edge, add node. So first of all, I will create the node for orchestrator. Bro, order pizza. You know what? I'm hungry. Orchestrator node, and the function is orchestrator node. Perfect. Then I want to create worker node. Yes. Then I want to create collector node. Yes. Perfect. Now let's create the edges. So it will start from orchestrator, then it will go to worker, then collector, and then end. Simple. And then let's say compile. Complex graph equals graph.compile, and let's see that particular thing visualized graph. Just to make sure the graph is fine. So this is the code for it. So here you can say complex graph. Perfect. Orchestrator node is not defined. Very good, because we didn't define it. Like we didn't run this. Let me just run. Let me click on run now. Simple. Perfect. Perfect graph. Perfect. Now the beauty of this graph is it looks very simple, but we know that what's going on here and what's going on here, right? So well done. And now let's try to execute our graph. Simple. So simply say complex graph dot invoke, and then I can say first of all query. I will say query what is the capital of France, what is the population of France, let's see. And let's add one more thing. And what is the capital of Germany and what is the population of Berlin? Wow, okay. Let's perform all of these things. So we have query ready. Now what do we have next? We have I think tasks and we will pass it, so it will be like empty list. Results will be empty list, summary will be empty. Simple. Now let's try to invoke it. Now let's see what we get. So we should see first of all tasks as well, we should see results as well, and we should see obviously summary as well. We should see everything. And let's wait. There are total 4 tasks by the way. Yeah, ideally there are 4 tasks. Let's see how many tasks LLM has generated once. Okay, let's see. So here I've got the error. Congratulations. Input to chat prompt template is missing values. Really? Let me see what is missing. So let's go to our collector node. Okay. So in the collector node we have passed the results. Okay. And oh no, we have just passed the results here. Okay. Then what is missing? Chat prompt template of results. Okay. Everything is fine. I didn't know that maybe it has not generated anything in the results. Maybe. So what I will do, I will generate the stream because only then I can see like what is happening. Okay. So let me just generate the streams. So where is the stream? Let me just get the stream node. Because I want to see what is the output of results. Because only then I can just leave everything. I cannot just go inside and see. So let's try to run the stream just to better understand what's going on. Okay, and here I will change this input with the previous one, with this one. And now let's see what's going on. Perfect. Jumped in complex graph. Let's try to see this. Let's see what exactly our each node is generated. That's why streaming is very, very helpful for the debugging as well. So orchestrator node has created 4 tasks. Wow man, this is amazing. So very good. And yeah, very good. So now next worker node will generate the thing. Let's see what it generates. Oh, okay, okay, okay. So worker node has completed the work, which is tasks is generated. Okay. Query is generated. Okay. Like queries are obviously okay. Results is there. Okay, results is generated. Oh, that's good. That is. And then we have a long data that we can show. That's not connection thing. That's not a big deal. And then it has generated, let's say, do you mean Paris, France, this? Okay, so we have, the main thing is we have results as well. Like if I just check my state, so I have results. So the saying input to chat on template is missing variables. Refusal tokens usage, and refusal during task collector node. So let me see the scrollable element. So what do you want to do? Everything is fine. Why are you still there? So for I chunk, okay, results, summary, okay. Okay, if I go to my collector node, so here we have the results. Okay, that is fine. We have the results. Let me just check. So bro, I fixed that. Do you know how? It was a very quick one. And I don't think like it should throw an error for this one. I also didn't expect this, but then I debugged it and it worked fine. So what was the issue? So when you just saw the output, you saw that we were generating so many material as well, right? Along with the each one. What I did, I simply returned only the content from the execute function. See, earlier it was this response, and then I have just credited the response for content, and now it's working fine. But so that means in the list we do not need to pass the unnecessary columns or unnecessary tokens, right? So now let's examine the output. So now you can see that, and we can also see this thing and this thing. So now we have got the final thing. So we have tasks created, 4 tasks, right? Perfect. We have the query that we passed obviously. And here's the result. What is the capital of France? Paris. And population, this thing. Then Berlin. And Berlin population, this thing. Simple. And then summary. Wow. Then summary. So you have everything in, like you have everything that worked in parallel, first of all. Then you submitted all of the tasks independently. And this way you can implement the worker orchestrator, you can say architecture with ease without any kind of issue. Okay? And just to be more professional, if you do not want to write this AI message, you can simply say dot content. And you already know this thing, right? So let's say you want to say summary, dot content. Simple. Not a big deal. So this architecture was a big one, and now you have mastered this one. Very well done and proud of you. So now let's talk about our other architecture, and it's called evaluator optimizer, and it is also called as generate and parity. It has like so many names, but
Oh man, it will overflow if I'll. So far I learned orchestrator, router, parallelization, parallelization, and simple normal one. Graph. Hmm. I want to test these all. How to okay. So suppose I want to build orchestrator workflow, orchestrator worker and collector workflow, or orchestrator worker collect workflow. So before that there was a router, orchestrator worker pattern. Agentic workflow architecture where a central orchestrator breaks a complex task into dynamic subtasks and delegates them to specialized workers. The workers execute the task in parallel, and orchestrator then synthesizes their result into cohesive final output. independently and often in parallel. Workers are typically scoped to a specific domain, tool, or data source. Example: database worker, API worker. Okay, got it. Hmm. What are you doing till late night? Vikku is live. Who is Vikku? Why are you suggesting my way? Very bad. Cloud code. No, no, I don't need cloud code. I need orchestrator worker pattern. Pattern. So I want to perform some real task. I mean, not that asking what is the orchestrator trader, orchestrator trader worker pattern. Okay, now there will be first thing. Uh, it will be something like orchestrator. This is going to create tasks. Then there will be worker. And third will be collector. Wow. So this is going to perform some task in parallel. It will trigger multiple threads. Imagine like this. Yeah. So it will execute this. Okay. Now I'm just thinking like what. Let's take a real world example. Orchestrator is going to do something. Uh, it's going to split the tasks into different. It's going to split a big task into a smaller uh, independent tasks. But I want to suppose, let's say, run 5 queries into the Snowflake and then give me the final report of those. So can't we do like first execute something in parallel as well as execute something in sequential? Synthesizer they are calling collector. Integrate and refine. Hmm. Okay, so let me do one thing. Okay. I will do one thing. Let's imagine it's an organize like you asked LLM. Let's say you are a wedding planner and can you the planning tasks. So its goal is to divide into different tasks, and for each task, then it has to do one thing. Then different tasks will be like a uh, details of. Hmm, I have better plan. Let's say you are a movie director, and now your task you are direct you have to shoot a scene of okay, dance in rain. Okay, let me make it more funny. Romantic dance in rain. And let's see how it's going to plan. So I'm expecting it to plan this and shoot the different scenes. Okay, not romantic dance only. Let's see how it goes. So I'm planning like okay, first I will give it as an input and then it's going to split it into tasks. Then it will perform different tasks and will get the result of all. Different patterns. Let's forget it. Orchestrator. Orchestrator worker pattern. I by 1B. So I'll say orchestrator. Worker. Okay, let me copy things from it. First thing is this one I need to copy. You did the same mistake. Okay, it will do one thing. It will. Okay, now I got this cell. I don't need to create tool. I just need to create first define. Okay, let me say from uh, identic import base model class. What we say? Hmm. What he is calling? First thing is typed LLM schema. Hmm. LLM. Okay, let me say base model, and I'm just expecting tasks. That will be list of string. You are calling it as a string, and okay, I will import field, and here description. A list of tasks, a list of task tasks to be performed by workers. Okay, list. This is the thing, and if I will call LLM uh, LLM format. I'm just using some random LLM structured. structured. Structured will be like LLM with structured output, and here we are going to pass uh, LLM schema. Okay, so we got new modified LLM and LLM with structured output. Dot invoke. You are a movie director and have planned to shoot romantic pic uh, song in rain. Huh? What the heck? Running, right? Bro, it's not showing something. I think it will take time because there will be a lot of things that. Let me go through, revise the code first. So this is the thing, this now graph schema you created tasks, list of tasks that you want to perform, query, query that you are giving, that user will give, and result, that list of result and summarizing. And I want to make it more better version. So I will be, let's say, scene number, and because you are a director, right? So it shouldn't be something simple. Bro, is it working also? It's or not working? Definitely the time that I believe something is wrong here. Hmm. Now it is running here only. Earlier it was not running. Cannot import name list from Pydantic. Oh, my bad. From typing import list. Use your brain, bro. It's generating different tasks. Perfect. Okay, so it's generating a lot of tasks if you see. Okay, so it's like we are getting the tasks from it. I will create one more. Uh, Generate a list of tasks to be performed by workers, and now class you will say prompt, no, prompt, Sheen schema. Okay, so base model I'm gonna call, and now what I'll do, tasks, not tasks, but you will say scene, scene number, and field you will say uh, short scene number. Okay, task description scene field description description short description. I will keep two description. Short description, short description about a scene. Okay, and detailed description about the scene. Okay, now I need to here give just uh, int you will say, and it will be a string, and it will be a string. Okay, also you have to add, let's forget about date and location, just three things is enough. Okay, so this is a let's call it LLM tasks, and let's call it LLM Sheen is equals to LLM dot with a structured output, and here we are going to call scene schema. So we got two things. Okay, so we have different kinds of LLM with different outputs. So let's say now the next thing is, okay, first thing is we need to create a node to generate different tasks. So let's create a graph schema. Create graph state or schema. Okay, I will call it custom graph schema. Custom graph schema, and here we are going to pass what? First thing, I won't use, I will use typing from typing import type dict. Just type dict, otherwise I need to type dict, and I will return type dict. Okay, why will it return, bro? What the heck you are doing? It's class. So now the next thing is, what are the tasks will be what I did in the last one. It will generate lot. So okay, so here we need, so first thing I will use the query. uh, it will be a string. Okay, user query I will say, user query. Second, tasks, tasks uh, list of a string, okay, different tasks for user query, okay. Finally, uh, so these are the tasks. Response says, oh, responses I will say, because it could be for anything. Responses for different tasks, okay. And finally we'll be having summary, a string summary about the suit, about the query. So this is our graph schema. Okay, now next thing is create different nodes. Okay, not different nodes. First create orchestrator node. So define node orchestrator trader. Okay, so you will say, okay, first thing is state. State is nothing but custom graph schema, and here you are returning again custom graph schema. Perfect. Now what exactly you are doing here? So first thing is you will get uh, query. So query is nothing but user state query. Okay, now you got query. Then second thing is now you need to call LM. So LLM tasks. So tasks will be, okay. So what one thing I will do, from chat, from langchain core dot messages import chat prompt template. Okay, perfect. So here you are going to say chat prompt template dot from template. So yeah, you can say prompt. It's our prompt. So prompt from template. How was it? Oh god, I forgot it. I always forget it too. I don't know what's wrong with me. Yeah, it's a system and all. It's list of messages. I don't know if you guys are able to remember it or not, but for me it's very difficult to remember the things. I'm very forgettive insan. So if you will make mistake, I will forget it quickly. System. Okay, you are an experienced movie director and having a lot of experience. Second thing, what is the another thing? It's a system user or human. Okay, now I template it. Can you create can you plan shoot for query? Okay, so I will say it user query and split it into different shots. Okay, you did it. Now you got prompt. Now you will say okay. Uh, Response is nothing but first you are giving prompt, then you are giving okay chain, not chain. So chain prompt you are giving, then prompt is passed to LLM tasks, and then you are getting so result, or you can say tasks, that will be chain dot. Okay, how we were getting, by the way, I just wanted to see. You will get the task right here. Okay, perfect. Chain dot invoke. Okay, now here first thing is user query is equals to query. Supposed to we okay, so whatever the query that we are storing in the uh, graph or in the state, we are giving it as a task. Perfect, perfect. It's so far it's going perfect. Now the next thing is we got the query, we got the list of tasks. I need to update. Goes to tasks dot task. Perfect. And finally you will return. Don't forget, return the state. Okay, now the next thing is worker node. Worker nodes. Default node executor. I will call it executor. Is it good to say call it executor? What is the percentage of battery in my phone? Okay, let's say node executor. So here we are what we are going to state, and here we are going to give custom graph schema, and again we are going to return custom graph schema. Finally, you got tasks you will say state of tasks. Okay, now you have got the different tasks, and for each task what you will do, you are going to create separate things. So I'm going to create a function define execute. Okay, what it will do, so simply it will execute task, I will call it, and task I will give it. So task, I will get the task from okay, let me say chat from template dot from template. Okay, now user system system, and you have you have to plot, shoot, you are a movie director and have to shoot this scene. So you will say okay. And now the second thing is user. An experienced movie director, let's say. It was human, right? Can you shoot this scene? Okay, you got prompt. Now LLM Sheen will be okay. It won't be like this. Chan will be okay. Here's first thing is why we are going to do prompt. We are getting prompt. Then we are feeding it, or we are passing its output to the you can say LLM Sheen, and it will generate output. So Chan dot invoke. Okay, now you will say hmm, you will generate a scene. It will generate a scene. Now whenever we are getting a response, we are getting message, right? AI message. So simply I will append it. So here invoke, and I will say okay, task, that we are giving input and task. So whatever we are getting result. Okay, now the thing is I don't know. Execute worker node from concurrent futures thread pool executor. Now you are worker node thread pool executor, length of tasks as executor, results future executor dot map execute, and you are mapping the this particular node to particular task. You are getting tasks. Okay, you are mapping for each task you are mapping this particular function, and for result in results future results dot append result. Stop it, bro. Let's make a 30 minutes more. I mean, I today I feel like I will have to extend a little bit. I don't know. Let's do it first. I have to shoot a video as well. Oh god. So here, okay, I got it. I think I already worked on it, these kind of things, but I don't remember sometime. Let's quickly let me do it. We have executed, so what I'll do with uh, thread pool executor max worker len of tasks. We have tasks, right? Tasks as executor, executor, and now what I result futures. Okay, executor dot map, you are going mapping, and you are mapping a function execute task. And what exactly you are mapping? Tasks. So it's like a map method, but here it's like going to wrap and create the threads. So for result in result futures, it's going to wait for them. So results, let's call it as results. Let's, it will be list, and it will be, so results. Oh god, append result, we are appending. Okay, finally we are doing this, and at the end what exactly we got the results. So now uh, what was the name of the responses? Responses is equals to, I will say it's better, I will say uh, state dot responses is equals to responses result results, and finally you are going to return state. So far it looks, everything is looking smooth. Okay, we have worker node, we have executor node, and let's create another node that will be summary node. Okay, summary. I think he also created one node, collector node. Let's call it collector node only. Collector. Okay, state custom graph schema, and we are returning custom graph schema. And finally what we are exactly doing, so whatever we are getting from this, so we need to pass it. So you will say results responses, uh, okay, state responses. Okay, now thing is, you will say summary llm, it's not invoke, can you summarize the shoot. Okay, now I'll call it like responses, and responses. Finally we got summary. So state of summary, this will be summary return state. So we got this. Now from Langgraph graph import state graph, and this will be like graph equals to state graph and custom graph schema you are passing, and now you are treating graph dot add node, and here you will pass like first node will be First node is nothing but node orchestrator. So I will call them orchestrator. Orchestrator is just to node orchestrator. Okay. Second, graph dot add node. It's like node executor, executor, and here you will say node executor. And third is graph dot add node, and okay, graph dot add is. So this will be like, here you are going to do these things in prep. So you will say, okay, I need to in like import start and end is. So first thing you are going to do, you are going to say start to orchestrator. Orchestrator. I mean, yeah. Oh, what? Orchestrator. Orchestrator. I will do it. Graph dot add is and orchestrator. 2, you are going to say executor. Exe. Oh, I make mistake. Exe. Executor. And graph dot add is executor, executor to uh, collector. Babu. Okay, graph dot add. My graph dot add is, and here we are going to add int. Let's see, I'm excited to see this. It's completely new. Okay, my bad. It needs one more thing. Collector. Perfect. And now let me print it. Printing, I don't know. Forget it. I forget it always. So I will say final graph is nothing but graph dot compile. Oh, found is ending at unknown target. As expected. Orchestrator. Perfect. Orchestrator, executor, collector. Now I'm just excited, so excited to see it, how it's going to. Oh, okay, okay, okay. It's not only query you need to give, it's like you have to give you shoot a romantic Song in rain. Movie song in rain. Okay, let me say Bollywood. In rain or on rain? On rain. In rain, okay. I believe. Yeah. Now second thing, in rain. Yeah. Okay. Now query. Second thing was tasks. So tasks will be. I forgot the way how to input it. Ah, it's correct, bro. Just little bit of confidence is required. Okay. Tasks, and third one was summary responses. Responses and summary. I think it will do it best. What is the graph schema? Query string, tasks, responses, and summary. Query, tasks, responses, summary. Bro, what the fuck? User query, query, state query. So what is the issue here? Perfect bad thing. Expected string got list. Oh what? Where expected string got list? I'm giving the string only, bro. 1 minute. Oh, let me go through it. So our first node is node orchestrator. First of all, it should be where is the अबे यार मेरा टाइम बर्बाद हो रहा है sorry where exactly issue is there I'm not getting it let me ask it close it यार ये where is this and can you check no I don't want to check everything don't allow Hey bro, fuck off. It's a small error and you are creating chunk of code. I mean lot of code. I am not getting output even. Uh, Where exactly I am getting error it is? Got string got list. Wait a minute bro. When I'm giving it list, let me call this first. Expected string got list. Okay. Scene number one, short description. Okay, so these are the different details. Perfect. Everything looks good so far. Here we got this short description. Description. Okay, things are look. So here, so far everything is looking smooth. Here we have task. We have summary string, responses list of string for different tasks. Let me do one thing. Uh, I will do one thing. I will call sirf graph dot add is orchestrator to end. Let's see how it behaves. Yeah, what happened? Let me do one thing. If we are not executing, this is the only thing, right? Pa- Still, expected string got list where? Hmm. Expected string got list where exactly is the issue then? Okay, one thing I found, it is somewhere here only. Oh man, it's 148. Today I'm gonna just miss my timing issue. Maybe one thing I need to do. हो जा भाई. Queries value. What the fuck? Chat from template. I'll see. चोट सारा सही था गड़बड़ okay, let me do one thing. Debugger and die. Run all. It will generate something strange. Should a romantic Bollywood movie song in rain? Len. I used somewhere Len. Where is Len? Okay, LLM schema. Somewhere we are getting LLM schema. Okay, identic model, right? So tasks will be quite heavy. Perfect. Let's do seat. Lot of content generated. Okay, so imagine you are artist first query shooter, then tasks, create tasks. Okay, summary at a starting, then execute a query shooter Bollywood rain in rain. Okay, after executor. I mean, I do not need to do this. I can run it directly and I can get the result. But yeah, I got it. Summary at the end, you can see. Very beautiful. Full body dance, a choreographed movements with safety measures on, wet surface, everything that mentioned properly. Finally, I did withdraw. I think one mistake can. I feel it's very important to say different tasks or different scenes, and then it is creating. Wait a minute. Scene number it's not giving perfectly. It is giving everything as scene number one because these are different independent tasks, right? So I will come around it like what exactly should be done. Suppose where you want to maintain something like here scene number you are getting right, scene number here also, everything it is giving scene number one. Okay, by the way, that's all for this video. So we are creating all the different steps. Thank you, and now I need to practice little English and then I need to jump into that. Okay, bye bye, and I'll see you next day. At least my internet is working perfectly. I hope so. All the best, guys, and take care. Sleep